So that region is called as saturation. So when the VDS is going to cross VDSat, we can say that MOSFET is going to enter what is called a saturation region, where you are going to have a very heavy amount of current flow. So whatever voltage you are going to apply across the channel is to be pinched off. Pinched off means it is a condition where there is nothing is in your hand. So VDSat is going to be very, very small when compared to VDS in saturation region. So for saturation region also, we are going to have the drain current equation. See, the same drain current equation we are going to take, and we are going to put VDS equal to VDSat. The only change, VDS equal to VDSat. And already we know that expression for VDSat. Already we have derived what is VDSat equal to VGS minus VT. So if you substitute that and if you simplify, you will get the final expression for drain current in the saturation region as like this: ID equal to VGS minus VT the whole square. Here you can see ID depends on V square. It's a square law dependence. So it is not linear. The voltage is independent of drain voltage, but drain current is dependent on square of your VGS. So the linearity is gone. The device is non-linear. That is why it is called as saturation region. And it is called as pentode region. Similar to pentode has this operation. Pentode is a device which is going to have 5 electrodes, and this operation is found similar to pentode. So this region is called as pentode region of operation. And in the saturation region, you can find the transconductance. Transconductance is differentiating ID with respect to VGS. So dou ID by dou VGS, if you differentiate this term with respect to VGS, you can get what is called as GM. And if you know the expression for VGS minus VT in terms of ID, you can get the expression for GM in terms of ID. So this, you can see that all depends on W by L ratio, width and length of your channel. It is going to depend on the drain current depends on W by L. The trans contents also depends on W by L. So this is about the different regions of operation of FET.